Okay, so today we're going to go over the CC1 1.1.2 review and preview. And we're going to start with problem number 10. So Janelle wants to challenge you to a toothpick and tiles game, which we did in problem 8 in class. Okay? So Janelle's going to use she's challenging you to use exactly 4 tiles to solve her challenges below. Justify your answers with pictures and labels. Okay, so the first challenge is to create a tile pattern where the number of toothpicks is exactly double the number of tiles. Okay, well, if we have to use exactly 4 tiles, we need 8 toothpicks. Okay, so I'm going to draw 4 tiles in a pattern. And then I'm going to draw my toothpicks around the outside because my tiles are my area. Toothpicks are the perimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have too many. So then I'm going to take my 4 tiles and do another pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That will not work. I'm going to go until I find a pattern where I have 8 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8. And then I have a picture. I need labels. 4 tiles, 8 toothpicks. Or I could label it as area, 4 units, squared, perimeter is 8 units. Okay, moving to Janelle's second challenge. We need to create a tile pattern where the number of toothpicks is more than double, more than 8. We already did that. Either of the 2 patterns, here or here, will work because both had 10 toothpicks. So I'm just going to copy one or both of the patterns. Make sure I draw my toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to label it. So 4 tiles, 10 toothpicks. And that label goes to both. Okay, looking at problem number 11. Today in the lesson today, we looked at the number of tiles and number of toothpicks used to form shapes made of square tiles as we played the toothpick and tiles game. The math words that also describe the number of tiles and toothpicks are area and perimeter. Okay. Instead of having you read the math notes box for this lesson to review how area and perimeter are related, we're going to talk about it here. And then we're going to solve the questions below. So as a reminder, tiles were area, toothpicks were perimeter. As a general rule, remember, area is always squared. We square our units. So that means if it's centimeters squared for area because we're multiplying. Okay? Also, as a reminder, area for a rectangle or a square is length times width. Okay. Perimeter, the units are what they are because we're using addition. We're adding around the outside of the shape. So we're going to start with this figure here. I could count the squares individually. That takes a long time. Or I could remember, hey, area is length times width. My length is 5, my width is 4. So 5 times 4 is 20. My label for my units of measurement, centimeters. And area is always squared, centimeters squared. Now for perimeter, I'm going to, I could draw the tiles, 1, 2, 3, 4, 5, 6. However, I know that there's 5 here and 4 here. So I could say it's 5 plus 5 plus 4 plus 4. 5 plus 5 is 10. 4 plus 4 is 8. 10 plus 8 is 18. And I can't forget to label my unit of measurement. Moving to part B, I'm going to do the same thing. Area is length times width. So 8 times 5, which is 40. The unit is centimeters. Area is squared. Perimeter, again, there's no tiles for me to draw toothpicks around, but I can remember, well, there would be 8 up here, 5 over here, there'd be 8 here, and there'd be 5 here. So 8 plus 8 plus 5 plus 5. 8 plus 8 is 16. 5 plus 5 is 10. 16 plus 10, 26, and I have to label it. For part C, we need to design our own shape with 5 square tiles. Then we're recording the perimeter and the area. So I need 5 tiles. It can be in any pattern. My pattern is going to look like this. You could have any pattern. It could be something like this. Or something like this. As long as you have 5 tiles. Now, I have to find the area and perimeter. I am going to be working with that shape. So my area, well, that's the amount of tiles I have. It's 5. However, we don't have centimeters or inches, so my unit of measurement is just units, and I need to square it. My perimeter, I have to draw my toothpicks or label my sides. Okay, so I could either label my sides or draw my toothpicks. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My unit of measurement is units. And if I had labeled it, I could say, well, 2 plus 2 plus 3 plus 1 plus 1 plus 1. 2 plus 2 is 4 plus 3 plus 1 plus 1 plus 1. 4 plus 3 is 7. 7 plus 1 plus 1 plus 1 is 10. Now, problem number 12. We're going to look at the first 3 figures of the pattern. So figure 1, we have a triangle. Figure 2, a square. Figure 3 is a pentagon. We need to draw what figure 4 will look like based off of this pattern. So figure 4, well, I'm going from a 3-sided shape to a 4-sided shape to a 5-sided shape. So figure 4 is going to be a 6-sided shape. Okay. What would figure 5 look like? Okay, for part B, using words, well, what's 5 going to look like? 5 should have figure 5 will have, if 4 has 6 sides, 5 is going to have 7 sides. Figure 6 will have 8 sides. Using words, describe how the pattern is changing. The shape is increasing by 1 side. Okay, problem number 13. We have Vi, and she's trying to figure out how a square can be divided into 4 equal parts. Show her at least 3 different ways to divide a square into 4 equal parts. So, remember, they're equal parts. I could do something like this. First of all, there's 6 parts, right? So that won't actually work. And I have to be careful because if I do this, are all those parts equal? They are not. So one way is, I don't know if any of you have parents that will cut your sandwiches. You could cut it in half and then half again, right? Or maybe you like triangles for sandwiches. Or, now I've never had a sandwich this way, but I know I could split it this way and they're all equal parts. I could also split it vertically into 4 equal parts. Okay. Moving to the next problem. Problem number 14. The band students at Tolt Junior High and Maywood Middle School have been invited to participate in the Evergreen Music Festival in Seattle. Each group has decided to have a car wash to raise money to pay for the trip. We need to use the graph below to answer the following questions. Part A, which school washed more cars? How do you know? Okay, specifically, I want you to use the words x-axis or y-axis. Okay, so if I'm looking at this graph, my number of cars washed is along the bottom here. So, if you recall, this line is the x-axis. The school that is the furthest over on the x-axis is the car that washed, which is the school that washed more cars. So, if I look at this map, or graph, sorry, I'm going to notice that Maywood Middle School is further over. Therefore, for part A, Maywood Middle School washed more cars because they are further right on the x-axis. Okay. Part B, which school has raised the most money so far, and how do you know? Use the words X or Y axis. Well, dollars earned goes up and down. So I'm going to look at my Y axis, which is the one that goes up and down. I'm going to look at the school that is closest to the top of my graph, which is Tolt Junior High. For Part B, Tolt Junior High raised the most money. They are higher on the graph than Maywood. Or I should say, instead of higher on the graph, I'm supposed to use the words X or Y axis. They are higher on the Y axis than Maywood. Okay. Third part. Find out how much each school is charging to wash a car. Show your work to justify your answer. So, I'm going to start with Tolt Junior High just because it comes first. Okay. So, Tolt Junior High earned $60. And if I go to my x-axis, I can figure out how many cars they washed. It's 5 cars, and they made $60. How much did they charge to wash each car? Well, I can think about it as if I divide 60 by 5, I find out that they charge $12 per car. Now I'm going to go look at Maywood. They did not earn as much money, so they are lower on the graph. They actually earned $20. However, they did wash more cars. They washed 20 cars. How much did they charge per car? Well, 20 divided by 20 is $1 per car.